All right, guys, so before we get started and finish up 4.5, are there any questions on any of the assignments thus far? Any questions on the homework assignments?
When did they do?
By next Friday. So, again, a lot of the solving, hopefully you've noticed or picked up at this point, when we're solving these polynomial equations, the graphing calculator is going to be your biggest tool for helping us solve them. And for a lot of them, because we finished up with that one, we're going to look at this one here. It can give us a lot, if not almost all of them. Because when we look at this one here, we want to find all the real solutions of x cubed minus 5x squared minus 2x plus 24 equals 0. And our goal is to get, or at minimum, we need n minus 2 solutions where n's the degree. So if we look at this problem here, the degree is 3. So 3 minus 2. If we can get at least 1, we can get it down to a quadratic using synthetic division, use quadratic formula, completing the square, different methods for quadratic. The next best is if we get 2. If we get 2 solutions, we can bring it down from a degree 3 down to a degree 1, our linear. Add or subtract, then divide, get x by itself, we're done. Or the best case is if we graph this and get 3 solutions, we are finished. We have all the solutions, we're done. So minimum, we need 1 for this here. Best case, we get 3, and we're finished. So if we look at this problem here, we can graph it. So we have x to the third minus 5x squared. Be helpful if we're not in the exponent. Minus 2x plus 24. Because we want to type that into the graphing calculator and tell it to graph this for us. And we see that it intersects the x-axis in 3 places. It looks like -2, 3, and 4. And if we want to make sure, we can go second graph and we can look at the table. I have to scroll down some to see this, but we do have, when x is -2, the y value is 0. When x is 3, the y value is 0. And when x is 4, the y value is 0. Because when we're looking for solutions, we're looking for values of x that will make the equation be 0. And in graphing terms, we're looking for the values of x that will make the y values be 0. So if we plug -2, 3, or 4 into this, it would make this equation true. It would make both sides be equal. And since it is a degree 3, we need 3 solutions. We have 3 solutions. We're done. That's it. We don't have to do anything else to this problem. Because if we did the synthetic division steps, we would still get these 3 solutions. Because I could put -2 in the cubby and do our synthetic division steps. And it's just proving that these are the solutions. I don't have to do this because we know we needed 3. We have 3, so we're done. Because if I did this here, we'd multiply -2 times 1 and put it under the 5. Then we would add straight down. -5 plus -2 is -7. -2 times -7 is positive 14. -2 plus 14 is positive 12. -2 times positive 12 is -24. And 24 plus -24 is indeed 0. So it's just reconfirming that this is a solution. We can do this again with 3. 3 times 1 is 3. -7 plus 3 is -4. 3 times -4 is -12. Add straight down, we do get 0. So it's telling us again, -2 and 3 are both solutions. Again, I don't have to do this because we know the graphing calculator already told us these are solutions. These are our values. And the remaining equation, remaining expression, our -4 is our constant term, the one without a variable. One's going to be the term with x, and if the number's in front of it, we just keep increasing that exponent's power. X minus 4. Solve for it, we get x equals 4, but the calculator already told us that. Does this make sense? So did we need to do the synthetic division? No. Because if I had only gotten 2 of those, I didn't get the third, then yes, I need to do the synthetic division to get that last solution. I do the synthetic division to get the remaining if I'm not able to find them all. But if I find them all, we're done. We have them. We don't have to do the synthetic division to get the rest because we already have them. So let's look at one more of these here. F of x equals 3x to the fourth minus 2x cubed minus 37x squared plus 24x plus 12. Since this is a degree 4, minimum we need to find 2. Because if I can find 2 solutions, we can use synthetic division to get it down to a quadratic. If I can find 3, that's even better because we can get it down to a linear. And if we find 4, we're done because we have all 4 solutions. Well, again, the first place I would start is in the graphing calculator. Three x to the fourth minus 2x cubed minus 37x squared plus 24x plus 12. We want to type it in that first line and have it graph it here. Now we do see that it intersects, it crosses the x-axis 4 times. So there are 4 solutions. There's 4 values of x that will make this function be 0. And if we look at the table, it only really gives us 1. Incidentally, it is 1. Because when x is 1, the y value is 0. Now, when x is 0, the y value is 12. That doesn't tell us anything. That just tells us what the y-intercept is. Because again, when we're looking for solutions, we're looking for what values of x will make the function be 0. So for solutions, all we know for certain is that x is positive 1. But again, we need 2. And if it doesn't give us 2, the only way for us to get 2 from here is either guess and check or the rational zeros theorem. And the rational zeros theorem states that we have plus or minus p over q, where p is the factors of the constant term and q is the factors of the leading coefficient. Constant terms are a term without x. And here our term without x is 12. So we need to see what numbers multiply together to give us 12. Well, 1 and 12 is a good place to start. 2 is also a factor of 12 because it'd be 2 and 6. And lastly, we have 3 and 4. We're just looking for the numbers that multiply together to give us 12. Q is the factors of the leading coefficient, the number in front of the variable with the biggest exponent. And that is 3. So we're looking for the factors of 3, the numbers that multiply together to give us 3. Well, it's 1 and 3. Because it's prime, there's only one set of factors. Questions on how we found the factors of P? Are these numbers for P or these numbers for Q? Now we're going to divide every P value by every Q value. And we're going to put plus and minus in front of it. So I always start with the first Q value of 1. We're just dividing by 1. Well, realistically, that's just going to give us these 6 values back. Because 1 divided by 1 is 1. 2 divided by 1 is 2. 3 divided by 1 is 3. 4 divided by 1 is 4. 6 divided by 1 is 6. 12 divided by 1 is 12. We're just putting them over 1, which is just going to give us the number itself. Dividing by 1 doesn't really do anything. And once we finish that, then we're going to move over and do the same thing with 3. So that's going to give us plus or minus 1/3. We will always have the 1. Because 1 over 3 is 1/3, it doesn't reduce. If you're not sure, we can grab the 30xs, tell it 1 over 3. Then our next one is going to be 2. So 2 over 3 would be plus or minus 2/3. One after that is going to be 3 over 3, which is 1. 3 over 3 is indeed 1. It's already listed. We don't have to list it again. 4 over 3 is going to be 4 over 3. It doesn't change. It doesn't reduce. It's just 4/3. Our number after that would be 6 over 3, which is 2. And lastly, 12 over 3 is 4. So those are already listed. We don't have to list them again. Questions on finding these rational zeros? Now, the nice thing with these rational zeros in the graphing calculator is we can use them together to eliminate choices. We know that positive 1 worked. It goes, well, the graph showed us it intersected at positive 1. But our negative 1, 2, 3, 4, 6, and 12, they don't cross at any of those. So positive negative 2, positive negative 3, positive negative 4, and positive negative 12 don't work. Even though we didn't specifically look at it on the graph, we are going to have 4 solutions. We see it crosses at those 4 spots. Positive negative 12 are outside the graph thing range, but it's not going to cross there. And really our negative case is out because positive is the only one that works. So now I only have 6 other options to choose from. 1/3, 2/3, 4/3, they're positive or negative values. We're ready to start checking those there. So 2 ways. One is we just use synthetic division until we find one that gets us a remainder of 0. The other is we can go second trace value, second trace enter. That first one lets us plug values of x in. And we can start with 1/3, 1 divided by 3. And if it gives us a y value of 0, we know it's a solution. And here it says when x is 1/3, the y value is 15.851852, this decimal. So that doesn't work. Now we can do second trace value again, and it will still do the same thing. Or if we remember, we can plug the next number in, so negative 1 divided by 3. And negative 1/3 gives us a y value of 0. So negative 1/3 is a solution. Then hopefully we could say 2/3 is a solution. Unfortunately, it's not. Negative 2/3 doesn't give me a y value of 0. 4/3 doesn't work, and negative 4/3 doesn't work. So our only 2 solutions for this here are 1 and negative 1/3. So now we need to set the synthetic division up to bring it from a degree 4 down to a degree 2 and to find the remaining solutions. Any questions on what we've done? Which number do we want to try first or do first? 1 or negative 1/3? Negative 1/3. So we'll put it in the cubby. We'll do our multiplication and addition. Again, if using a calculator helps with these steps, use it. Because we could do negative 1/3 times 3 is 1/3 is negative 1. Then we're going to add negative 2 plus negative 1. This is negative 3. Then we're going to multiply again. Negative 1/3 times negative 3. 1/3 times is 1. Negative 37 plus 1 is going to be negative 36. And then we're going to multiply. since I'm already right here, negative 1/3 is 12. 24 plus 12 is 36. Negative 1/3 times 36 is negative 12. And negative 12 plus 12 is indeed 0. So we can do these in the calculator. We can do each part of this step. We can't do the whole thing, type the whole thing in, but we can do each of the multiplication and addition steps in the calculator. It will do it for us. And once we finish that, we're going to do this again with 1. Now 1 times 3 is going to be positive 3. Negative 3 plus 3 is 0. 1 times 0 is 0. Negative 36 plus 0 is, well, negative 36. 1 times negative 36 is negative 36. And 36 plus negative 36 is indeed 0. Questions on how we got to this point here? Now we do need to fill our variables back in. The negative 36 is our constant term, our term without x. The 0 would be the term with x, and our 3 would be our term with x squared. We keep increasing that exponent as we have terms. So it tells us our final expression, once we did this division twice, is 3x squared minus 36. And again, we're wanting to solve this. We're wanting to see what values of x is going to make this equal 0. Do we have a middle term? Do we have an x term? So we can still do the quadratic formula. We can still do completing the square. But if we just have that x squared term, it's going to be so much easier to square root method. If we don't have x to the first, we don't have just, and we only have x squared, get it by itself. We can add 36 to both sides, because negative 36 plus 36 is 0, leaving us with 3x squared is equal to 36. The x squared term is still not by itself, so we would divide both sides by 3, telling us x squared is equal to 12. Is the x squared term by itself? Yeah. Because once we get it by itself, we can take square root of both sides, because the square would cancel, telling me that x is equal to plus or minus, because we have to put the plus or minus whenever we take the square root of both sides. And the square root of 12 can reduce to 2 square roots of 3. So it's telling me that those last two solutions, those last two places it crosses the x-axis, is at positive negative 2 square roots of 3. And that's it. So our solution for this here, the values of x that will make this be 0 is 1, negative 1/3, and positive negative plus or minus 2 square roots of 3. Those are our 4 solutions for this here. Questions on this here? The last theorem for 4.5 is the irrational conjugates theorem. This is nice to know because what it says is that if a plus the square root of b, if this is a solution, then a minus the square root of b is also a solution. If we have one, we have to have the other. If we have a square root term, so positive square root of 3, we have to have the negative square root. Kind of like with a plus bi and a minus bi. If we have one, we have to have the other. They always come in pairs. Our irrational solutions come in pairs, our plus and minus. We have to have both. That is why we had here 2 squared roots of 3 and negative 2 squared roots of 3. If I have one, I have to have the other. They're always going to come in pairs. So what we're actually going to do is work backwards for this here. They're going to give us the zeros. We have to find what the equation is that made it up. So we want to write a polynomial of least degree that has rational coefficients and a leading coefficient of 1. All that's saying is that it's the smallest degree we can have with these solutions. They're not going to be fractions. And the number in front of our variable at the biggest exponent, our leading coefficient, is going to be 1. But it told us the zeros, the solutions. It's telling us that 1, x is equal to 3. 3 is a 0. 3 is a solution. So for this here, x has to equal 3. That's one of our solutions. It also told us that x is also equal to 2 plus square root of 5. This is a solution. This is a value of x that would make whatever this polynomial is be 0. Now, also because of our complex conjugate theorem, it says that 2 minus the square root of 5 has to be a solution. If a plus the square root of b is a solution, a minus the square root of b is a solution. If a minus the square root of b is a solution, a plus the square root of b is a solution. And we start off by setting these here, and we're going to work backwards, kind of like with factoring. We're starting off with the solutions. We're going to work with the polynomial that we started with. Kind of like with solving factoring. We started off with the polynomial, we factored it down, set it equal to 0, and solved. So really the first thing we want to do with this here is get each of these back equal to 0. We're going to get them back in what they call the factored form. So here we're going to subtract 3 from both sides, telling us that x minus 3 is equal to 0. So one of the factors that we have is x minus 3. We have to do a little bit more with the 2 plus the square root of 5. Because just like the first one, I can subtract 2 from both sides, telling me that x minus 2 is equal to the square root of 5, but again, we need it equal to 0. So we're also going to subtract the square root of 5, telling us that x minus 2 minus the square root of 5 is 0. So that's our second factor. And we're going to have to do it one more time with this one here. So we'll minus 2 first. This time we're going to add the square root of 5 because the square root of 5 on this one was negative and not positive. Questions on this so far? So the whole goal is just to get them all equal to 0. Now as we worked with this, with solving, we would get the polynomial factored as multiple things multiplied together to equal 0. And if we have that according to the zero product property, one of them has to be 0, so we set them all equal to 0. So working backwards, we're going to now take each of those expressions and multiply them all together. Now at this point here, we're not going to set it equal to 0 because we really aren't worried about solving. We were just using that, setting them equal to x and then getting them equal to 0 to get it in factored form, to get it in a form that where we can actually get to the polynomial an expression itself. Now we have to multiply these out. We can, if we wanted to, we could do the x minus 3 times our x minus 2 minus the square root of 5. I would not advise that because we're going to have a lot of terms that won't simplify. It's going to be better a lot better and a lot nicer to multiply our complex conjugate terms or our irrational conjugate terms, our conjugate terms expressions first. Because when we multiply this here, we're going to distribute the x across. So we're going to say x times x is x squared. X times negative 2 is negative 2x. X times the square root of 5, positive square root of 5, is going to be positive x square root of 5. We can't multiply the x inside the radical. The only way we could is if x was also inside the radical. It's just multiplying outside. Then we'd move on and multiply through by negative 2. Negative 2 times x is negative 2x. Negative 2 times negative 2 is going to be positive 4. Our negative and negative make positive. 2 times 2 is 4. 2 times our positive square root of 5 is going to be negative 2 square roots of 5 because our numbers multiply outside. And then lastly, we're going to distribute the negative square root of 5. Negative square root of 5 times x is going to be negative x square root of 5. Negative square root of 5 times negative 2. The negative and negative to make a positive. 2 times square root of 5 is 2 square roots of 5. And lastly, negative square root of 5 times positive square root of 5 is going to be negative, but we can multiply what's inside, 5 times 5, giving us the square root of 25. Now we do need to condense. We need to simplify some of these terms because there are a lot of terms, and funny enough, it's going to simplify down to 3. I'm going to start with the variable with the biggest exponent, x squared. It's the only one that has x squared, so that's as simplified as it gets. Negative 2x and negative 2x give us negative 4x. X squared of 5, negative x squared of 5. That is 0. X plus negative x, x minus x is 0. It doesn't matter that we have square root of 5. They are like terms because of the x squared of 5. We have one of them minus 1. 1 minus 1 is 0. Negative 2 square roots of 5 plus 2 square roots of 5 is also 0. Now we do have our plus 4 minus the square root of 5. Well, or not square root of 5, square root of 25. But the square root of 25 is 5. Now really we have what? 4 minus 5? We could rewrite that whole thing out or just change it to what? 4 minus 5 is negative 1. So if we really wanted to, instead of writing negative square root of 25, we could have just written that as 5. That's a square root times a square root squared. Simplifies. Questions on this here? This is part of the reason why we would want to multiply those conjugates together is because all the radical terms, all those square root terms are gone. They simplify each other out. If we had multiplied one of them with the x minus 3, they would not have simplified until we did the multiplication with the other one. There's going to be a lot more terms. Now we just need to finish by distributing. X times x squared is x cubed. X times negative 4x is negative 4x squared. X times negative 1 is negative x. Do the same thing with negative 3. Negative 3 times x. Okay. Negative 3 times x squared is negative 3x squared. Negative 3 times negative 4x is plus 12x. And negative 3 times negative 1 plus 3. Finally, we'll finish combining like terms. We'll have x cubed. Negative 4x squared minus 3x squared is negative 7x squared. Negative x plus 12x is plus 11x. And our constant term of positive 3 is just going to say plus 3. So the polynomial of least degree with leading coefficient of 1 for these zeros is x cubed minus 7x squared plus 11x plus 3. Questions on this here? Any questions on what we did on this one? Yes. We're going to do one last one. We're going to do the last one on that next page. This one here tells us that the zeros are 0, 5, and negative 5 plus the square root of 8. So for this one here, we know that our zeros that they told us so far, what x is equal to. X is going to be equal to 0, x is going to equal 5, x equals negative 5 plus the square root of 8. But it also means that x has to equal negative 5 minus the square root of 8. Now, out of all of them, the x equals 0 is the nicest one out of the group. It's already equal to 0. It's already in factor form. We don't have to do anything to it. Just x equals 0. Now, x equals 5. We do need to get it equal to 0. We'd add 5. Really telling us that the factored form of a solution of 5 is x plus 5. Or, sorry, not plus. What am I doing? It would be not plus, but minus. Because 5 minus 5 would indeed give us 0. If we added, it would have given us 10. So x plus 5 equals 10. We need it equals 0. Now the x equals negative 5 plus the square root of 8. This time we would add 5, because negative 5 plus 5 would give us our 0. Telling us x plus 5 is equal to the square root of 8. Minus the square root of 8 from both sides. Telling us x plus 5 minus the square root of 8 is equal to 0. Got to do it one more time. We are going to add 5 first, just like before. Telling us x plus 5 is equal to negative square root of 8. But this time, instead of subtracting the square root of 8, we're going to have to add it. To both sides. Telling us that the 4 factors of this here, the 4 factors of our solution are going to be x minus 5, x plus 5 minus the square root of 8, and x plus 5 plus the square root of 8. So we're going to have to multiply these 4 things out. Questions on how we got here? Now, is there any theorem or anything we've come across that says we have to multiply one thing at a time? That we can only multiply 2 of these parentheses. We can't multiply more than 2. Well, yes, I can't multiply x through all 3. That doesn't work. But if we wanted to, x times x minus 5, we can multiply those 2 first. And if I multiply those 2, x times x is x squared. X times negative 5 is negative 5x. We only multiply those 2. We can also multiply these other 2. We're doing them independently. We're not spreading it across more than one set of parentheses. We're just doing those 2 individually. right next to each other. X times x is x squared. X times 5 is plus 5x. X times the square root of 8 is plus x square roots of 8. Then we'll move on and distribute our positive 5. 5 times x is plus 5x. 5 times 5 is plus 25. And 5 times positive square root of 8 is plus 5 square roots of 8. And lastly, we'll distribute the negative square root of 8. Negative square root of 8 times x is negative x square roots of 8. Negative square root of 8 times 5 is negative 5 square roots of 8. And negative square root of 8 times positive square root of 8, it will be negative. Square root of 8 times square root of 8 is 8. Because square root of 8 times the square root of 8 would be the square root of 64, which is an 8. Or we can say the square root of 8 squared. Squared would cancel. Now, once we get this whole thing, we'll need to simplify. X square roots of 8, negative x square roots of 8 cancel. 5 square roots of 8, negative 5 square roots of 8 cancel. X squared does not have any like terms. Our x term, we have 5x plus 5x, which would be plus 10x. And 25 minus 8 is positive 17. Now, last thing we need to do is do our last multiplication, multiplying these through. So x squared times x squared is going to be x to the 4th. X squared times 10x is going to be plus 10x cubed. X squared times 17 is going to be plus 17x squared. Now we're going to distribute the negative 5x. Negative 5x times x squared is going to be negative 5x cubed. Negative 5x times negative 10 is going to be negative 50x squared. And lastly, negative 5x times 17 is going to be negative 85x. Combine like terms. X to the 4th doesn't have any like terms. 10x cubed minus 5x cubed is going to be positive 5x cubed. 17x squared minus 50x squared is going to be negative 33x squared. 85x does not have any like terms. Telling us our final expression is x to the 4th plus 5x cubed minus 33x squared minus 85x. And that's it. That's the end of 4-5. We have one last section we're going to cover. Then we will review and test next week.